As a sysadmin, you may be asked to control access to a couple of services based upon day and time. For example, the company intranet server should only be available from Monday to Friday between 8 a.m. and 6 p.m. In this lecture, I'll show you how to filter traffic based on the date and time the packet is received, generated, or routed. There is the -m time match that is very flexible and has many options like datestart, datestop, timestart, timestop, month days, and week days. You can see all options by running IPTables -mtime --help. These are all options of -mtime match. Note that by default, NetFilter uses UTC and not the system time. On my computer, it's East European time, which means UTC +2. So the UTC hour is 14, not 16. The ---- kernel TZ option makes NetFilter use the system time instead of UTC time. But pay attention, I've seen different Linux distributions that used only UTC even though kernel TZ option was given. Let's move to a terminal and take a look at some examples. In the first example, I want to permit SSH traffic only between 10 a.m. and 4 p.m. on weekdays, and in the second example, I want to allow access to a specific website only after working hours. We suppose this machine is the router. I'll create a script and write all IPTables rules in that script. First, we flush all chains because we'll execute the script many times and don't want the rules to be added each time we execute the script. We want to permit incoming SSH traffic only between 10 a.m. and 4 p.m. or 16 on weekdays. So IPTables -a input -p TCP -d port 22. This is SSH traffic -m time --time start 10:00 and --time stop 16:00 -j accept. Use 24 hours format when writing the time. And another rule that drops packets if time is not between that time interval. This is necessary only if the policy is set to accept. In fact, it's the same rule, but without the -m time match. This is the second rule. And of course the target is drop. The rule on line number 6 will drop packets that haven't been accepted by the rule on line 5. I'm saving the script, then make it executable and run it. From the other Linux host, I'll connect to the firewall using SSH. And SSH is working. Packets are permitted. I'm listing the firewall. And we notice that 13 packets have been accepted by this rule. We are in that time interval. Look how it used UTC and not East European time. So in fact it's 14, not 16. To test it properly, I'll change the time when the rule that accepts the traffic is active. Let's say that the traffic will be permitted only between 3 and 5 AM. 3 and timestop is 5. This is AM time. I'm saving it and then run it again. From Linux 2, I'll try to connect using SSH to Linux 1. And it's not working. The rule that accepts SSH traffic is not active at this time. It's active only between 3 and 5 UTC. We notice 5 dropped packets by the second rule. Let's move on to the second task. We want to allow access to a specific website, let's say www.ubuntu.com, only after working hours. This machine is the router, and this is routed traffic, and that means the forward chain. In the same script, I'll add a rule to forward chain that matches HTTPS traffic to www.ubuntu.com. IPTables -a forward -p TCP -d port 443. This is HTTPS -d www.ubuntu.com. And now matches related to time. -m time -time start 18. This means 6 p.m. UTC -time stop 8:00 -j accept. And the rule that drops outgoing HTTPS traffic to www.ubuntu.com. This is the traffic that hasn't been accepted by the first rule. This is the second rule, and it has the drop target. If the destination IP address is that of the domain www.ubuntu.com and time is between 18 and 8, the packet will be accepted. Otherwise, it will be dropped by the rule on line 10. I'm saving the script and running it. We notice the rules that accept packets destined to the IP addresses of www.ubuntu.com between 18 and 8 UTC, and the rules that are dropping the traffic to the same domain name or the same IP addresses if the time is not in that interval.